All right, let's look at accessory organs. So the main accessory organs we're going to look at are hair and nails, but we're going to look at some other smaller organs that we have in our skin as well. So hair and nail, just to let you know, are made of a hard keratin, while skin is made of a soft keratin. So let's take a look at hair. So hair is in a hair follicle. So this is the hair itself. The follicle is the tissue around the hair. So this is a tube-like depression in the skin in which the hair develops. Now, if we look at distribution and types, we have about 5 million hairs on the human body, most of which are on the general surface. 98% are on the general surface, meaning not the head. So we have about 100,000 hairs on our head. Well, some of us have more than others. So looking at types of hair, one type is called vellus hair. That's a typical body hair. So what we find on our body. Next is terminal hair. And terminal hair is hair on the head, eyebrows, eyelashes. And after puberty, we'll get in other areas. So we'll get in the axillary and pubic hairs, axillary, armpit, male facial hair, and some hair of the trunk and limbs. The last type of hair that we can produce is called lanugo. And lanugo is a fine, downy, unpigmented hair that's found on a fetus. And it's found in the last 3 months of development, and then it falls off. All right. You can see lanugo typically on a premature baby, but not a fully a baby that has gone full term. So let's take a look at the structure of hair in the follicle. So down here, so this is showing the hair. So down here at the bottom of the hair, this is where we find the hair bulb. So this is a swelling at the base, and that's where the hair originates. So the root is the remainder of the hair that's in the follicle. And then the hair shaft is the portion of the hair above the skin surface. Now, the root and the shaft both contain dead skin cells. Next is a hair papilla. So this is the hair papilla right there. So this is a bud of vascular tissue there, and that provides nutrients for the hair. All right. So let's take a look. So the hair matrix right there within the bud, that's the hair's growth center. So let's take a look at the hair in cross section. So this is showing the hair and the follicle in cross section. All right. So the first is the medulla. So this kind of, if you follow this, that inner portion, kind of that lighter blue area there, that is medulla. So whenever we have, say that we have a medulla, the medulla is the inner portion. We have a cortex, the cortex is the outer portion. So the medulla is a core of loosely arranged cells and air spaces. It is found in thick hair, it's absent in thin hair. Around that, kind of that purplish area there is the cortex, and so this is a layer of keratinized cuboidal cells. And then outside of that, shown here in brown, is the cuticle, which is the surface layer. All right, let's take a look at some structures going back here. So structures associated with the hair follicle. The first are hair receptors. So you can see this yellow is trying to show nerve fibers wrapping around the follicle. So those hair receptors, these are nerve fibers that respond to hair movements. So if I move the hair, that's going to move the hair in the follicle, and that's going to be sensed by those hair receptors. And this, for a large reason, is why we still have hair on our body, is to feel things that might get on our body. Oh, humans had a reduction in hair on our body because it helps our evaporative cooling. We sweat more easily and lose heat more easily having less hair on our body. Next is erector pili muscle. So this is erector pili muscle here. This is a smooth muscle that causes the hair to stand on end. So, we contract the erector pili muscles when we're cold, and that makes the hair stand on end. You're also going to contract that when you're scared, also causing the hair to stand on end. Now, erector pili muscles are vestigial organs for humans. So a vestigial organ is an organ that was functional in an ancestor, but no longer functional in the current organism. All right. So by causing hairs to stand on end when you're cold, that creates the hair to stand up and creates a lot of air pockets between the outside air and your skin, And by creating those air pockets, air is a poor insulator, and so poor conductor of heat, I should say. And so this helps keep you warmer. And so that's why dogs and cats and so on will do that. So you'll also contract this when you're scared. Now, if you've ever seen a scared cat, its back is arched, tail's in the air, hair standing on end. It's trying to make itself look more intimidating and bigger, right? And so if you get scared, same thing will happen to you. But once again, that function is lost on humans because you do not look larger and more intimidating. All right, let's take a look at hair texture and color. So texture, so we're going to take a look at the texture and looking at the differences in cross-section. So if you have straight hair, like these two ladies here, your hair is oval in shape, all right? If you have so your hair is circular, right? Is round in cross-section, sorry about that. If you have wavy hair, here your hair is oval in cross-section. And if you have curly hair, your hair is relatively flat, and I don't have a picture of that one. So if we look at color, if you have brown to black hair, you have high levels of eumelanin, all right? If you have red hair, you have low levels of eumelanin and high concentrations of pheomelanin. If you have blonde hair, you have intermediate amounts of pheomelanin and very little eumelanin in your hair. If you have gray hair, basically when you get gray hair, you have a mutation, so you stop production of the melanin here. So with gray hair, you have little melanin, and you get air in your medulla. If you have white hair, you have no melanin. So once again, you also have air in the medulla. If we look at hair growth, going to go back to this picture here. Hair growth is similar to skin growth. So we have a stratum basal there. Stratum basal makes new keratinocytes, and those keratinocytes are pushed into the matrix. And so as those cells move up, as new cells are made underneath those cells will begin to die. So same kind of process in there. The difference is that hair grows in cycles. So the first phase is called an anagen phase, and that's where we have hair growth occurring, all right? The second phase is called the catagen phase, and that's where the base of the hair dies. All right, so the base of the hair dies. And lastly is the telogen phase, and that's where the hair rests in the follicle. So after the hair dies, the hair can just rest in the follicle. Now the hair may fall out at the catagen or telogen phase. So once the base of the hair dies in the catagen phase, the hair could fall out, or it could rest in there in the telogen phase for a little while before it falls out. Hair growth in most parts of the body is 2 to 3 months, so the length of the anagen phase determines how long the hair is going to be, okay? So if it grows for 2 months, it's going to be pretty short hair. 3 months, it's going to be a little longer. Hair on the head has an anagen phase of 6 to 10 years, and that's why hair on the head, also male facial beard or facial hair, can grow very, very long. You lose about 50 hairs on your head per day, which means 50 new hairs start to grow per day. Hair functions, one is sensation with touch there. All right, hair on the head has a couple of functions. It guards against heat loss, probably not as much as you ever heard. It's basically the surface area of your body. That's how much heat loss you would restrict from that. Okay, so this is why in the winter, me being somebody who doesn't have hair, I always have a hat on because my head gets cold. Hair on your head also protects you against sunlight. So think about like if you've ever been underneath, an umbrella during this, sitting outside on a patio, and there's a table umbrella there. It blocks the sun directly hitting you. It helps keep you cooler. Your hair does the same thing to your head. All right. We also have hair in our nose and ear canals, and that's going to help prevent entry of foreign objects. Okay, let's move on to nails. Nails are protective coverings at the ends of fingers and toes. So what we see here, and nail growth is similar to skin growth. So we have new keratinocytes made. We have new keratinocytes made here, and as they are made, they push the older ones further up, and so on. And so that kind of follows the same progress there. Let's look at glands in the skin. The first are sudoriferous glands, also known as sweat glands. And we have two types of sweat glands. We have eccrine or merocrine sweat glands, and the other are apocrine sweat glands. Now the merocrine or eccrine sweat glands, they produce a watery perspiration. So we use this for temperature control, and these are found all over the body. And I'll just let you know, because this opens up in a pore, we actually lose about 500 milliliters of water off our skin per day. And this is known as insensible perspiration, and those come out of our sweat glands. Next are apocrine sweat glands, so this deeper down, a little larger here. These produce a thick, milky perspiration. These are found in the pubic, anal region, axillary, areolar, and beard of males. And supposedly they secrete an odor that is attractive to the other sex. Next are sebaceous glands, so this is a sebaceous gland here. So these produce an oily secretion known as sebum. And these are associated with hair follicles, all right? So sebum lubricates the hair as it grows, and it also moisturizes the hair in the skin. Next is ceruminous glands, not shown here, but ceruminous glands secrete cerumen, which is earwax. So these are found in our external ear canal or external auditory meatus. And cerumen is really a combination of sebum and dead skin cells. Lastly are mammary glands. Mammary glands produce milk, and they are actually modified sweat glands.